Welcome to The Explainer. Today we're putting on our detective hats because, well, we're opening up a forensic investigation. We're looking at a hidden, microscopic underworld. I'm talking about an ecosystem that exists right under our feet, inside our walls, and quite possibly right above your head up in the attic. We're tracking down the hidden housewreckers. You know, those wood-destroying insects that treat our biggest financial investments like an all-you-can-eat buffet. So let's learn how to profile these suspects and really understand the science of how to stop them in their tracks.
Okay, let's dive into this. Take a look at this crime scene right here. This is severe structural damage, just hiding in plain sight. From the outside, it honestly just looks like ordinary, slightly rotting wood, right? But underneath the surface, it's been completely hollowed out. So here is the million-dollar question. What is silently eating your house right now? Because to the untrained eye, this kind of damage often goes completely unnoticed until it is way too late. To solve this case, we've got to learn how to identify the culprits.
And that brings us to our usual suspects. We've got the ant on one side and the termite on the other. People confuse these two all the time, especially when they suddenly swarm out of a baseboard, which is terrifying. But forensics tells a completely different story. Look really closely at the visual clues here. Notice the termite's broad, thick waist compared to the ant's pinched waist. Look at their antennae. The termites are perfectly straight, kind of like little strings of beads, while the ants are distinctly elbowed. Oh, and if you happen to catch them flying, termite wings are exactly equal in size. That's actually what their scientific order, Isoptera, translates to, equal wings. Ant wings, on the other hand, are totally unequal. Their front wings are way larger.
So the crucial point is that they don't just look different. Their actual motives for destroying your wood are entirely different. See, termites are in it for the nutrition. They actually digest the cellulose found in the wood. Carpenter ants, on the other hand, they don't eat the wood at all, not a single bite. They just excavate it to build their nests. If you find a gallery up in your rafters that's incredibly smooth, almost like somebody went up there and sanded it, and it's completely free of the muddy mess that termites leave behind, well, you're dealing with ants, not termites.
Now you might be wondering, how do termites actually digest solid wood? I mean, it's wood. Well, they literally can't do it alone. They need help from microscopic protozoans, bacteria, and special enzymes. But here's the kicker. They aren't born with these little biological helpers. They have to acquire them through a process called trophallaxis. Brace yourself, because it is exactly as gross as it sounds. Trophallaxis is the sharing of food and these helpful microbes through mouth-to-mouth or, yes, anus-to-mouth feeding among the colony members. Yep, nature is beautiful, right?
Let's see how this actually builds into their life cycle. Step 1. The worker termite ingests the raw wood. Step 2. They use that lovely trophallaxis process we just learned about to pass the necessary microbes all around the colony. The nymphs actually get their protozoa directly from the adult workers through this very intimate food sharing. And finally, step 3, those shared protozoa, bacteria, and enzymes get to work breaking down that tough cellulose into usable energy. It's wild. It brilliantly shows just how ridiculously interdependent a termite colony really is. A single termite on its own, basically harmless and starving.
So let's profile our chief suspect. Meet the eastern subterranean termite, or Reticulotermes flavipes. This guy is the most common wood-destroying species in the entire United States. They typically swarm in early to late spring, and you can actually identify the soldiers by their perfectly smooth mandibles. But what makes them so formidable isn't their bite, it's their sheer numbers. A single colony isn't just a few dozen bugs. No way. We are talking anywhere from 50,000 to over 350,000 individuals, all operating as one massive, hungry superorganism right inside your walls.
But believe it or not, they aren't even the worst offenders on our list. Enter the Formosan subterranean termite. You can spot the soldier caste of this specific species by their distinctive teardrop-shaped heads. They were first collected in South Carolina back in 1957, and they act as a highly destructive invasive force. So how did they spread so effectively throughout our southern coastal communities? Well, it was a brilliant Trojan horse situation. Their colonies hitched rides inside recycled railroad timbers. They infiltrated completely unknowingly, and when they set up shop, they established colonies that can easily exceed 1 million termites. That's 1 million hungry mouths per colony.
And this brilliantly illustrates how we actually track these pests when we can't see the bugs themselves. We look for their droppings, which we call frass. See, drywood termites require absolutely no contact with the ground, so they don't leave those muddy tubes you might be familiar with. Instead, they leave these pellets. If you find little piles of what looks like sand or seeds near a windowsill, look closer. Drywood termite fecal pellets are hard, dry, and have an elongate oval shape with rounded ends and exactly 6 concave sides. This is literal fingerprint evidence. Because these pellets don't change in shape, size, or color over time, finding them is a dead giveaway of exactly who your culprit is.
But termites and ants aren't the only ones leaving clues behind. Wood-boring beetles are notorious housewreckers too, and you can actually profile exactly which beetle family is chewing up your home just by reading the texture of the dust they leave behind. True powder post beetles leave behind a super fine, silky frass without any pellets at all, and they strictly attack hardwoods. False powder post beetles, they leave coarse, tightly packed frass, and they'll go after both hard and softwoods. Meanwhile, anobiate beetles leave elongated, loosely packed frass, and they strongly prefer wood with a high moisture content, specifically anything over 15%.
Then there's the old house borer, which is part of the Ceramyxidae family. The evidence they leave behind is highly specific. When they emerge from the wood, they chew these distinct oval-shaped exit holes that are about 1/4 to 3/8 of an inch wide. And here is the great irony of this bug. Despite being named the old house borer, their MO is actually attacking softwoods that are less than 10 years old. Go figure.
Section 2. The Exterminator's Arsenal. Science and Toxicology. All right, so we've learned how to identify the culprits and read the crime scenes. Now we need to transition our investigation from profiling the enemy to neutralizing them. The foundational weapon in this arsenal is the pesticide. The word itself comes from the Latin suffix "cide," which simply means to kill. But legally and scientifically, it's defined as any substance or mixture intended for preventing, destroying, repelling, or mitigating a pest. It's a massive, broad definition that covers a whole world of chemical engineering.
Now, what's really interesting about this slide is the sheer scale of the science involved. There are currently over 900 active ingredients used in pest control. That means 900 distinct chemical compounds perfectly engineered to interact with the unique biology of different pests. And from those 900 active ingredients, the industry has formulated over 20,000 different pesticide products. Over 20,000. This isn't just a matter of indiscriminately spraying a can of bug spray. It is a highly specialized, tactical market where exterminators select the precise formulation needed for the exact species they're fighting. But how do those thousands of products actually work? Well, they generally target the insect through 3 main routes of entry. First up, stomach poisons. These have to be swallowed by the pest, often through baits or liquids, taking full advantage of behaviors like grooming or, hey, that gross trophallaxis process we discovered earlier. Second, contact pesticides. These are designed to physically penetrate the outer body wall or the feet of the pest when they simply walk across a treated surface. And third, fumigants. These enter through the respiratory system. We're talking gases like methyl bromide or sulfuryl fluoride that can penetrate deep into those hollowed-out wood galleries to eliminate the entire colony at once.
But chemical poisons aren't the only way. There's also a brilliantly simple physical approach called the desiccant strategy. Instead of poisoning the insect's nervous system, desiccants like diatomaceous earth or silica aerogel work mechanically. See, insects have this incredibly thin, waxy outer layer on their cuticle that acts like a seal to lock moisture inside their bodies. Desiccants physically damage and scratch up that waxy layer. Without it, the insect literally dries out and dies of dehydration. It is highly effective, and what's amazing is that it's a physical attack, meaning the pests can't easily build a biological resistance to it.
So, we've covered the suspects, we've analyzed the clues, and we explored the chemistry used to stop them. Let's end with a quick quiz pulled straight from our forensic files. Which of these termites attacks wood with a moisture level of less than 15%? Is it A, the Formosan, B, the eastern subterranean, C, the desert, or D, the powder post termite? Think back to our lesson on those 6-sided frass pellets. The answer is D, the powder post or drywood termite. The clues are out there, hiding in plain sight inside your own home. You just have to know what to look for. Keep investigating, keep your eyes peeled, and we'll see you on the next explainer.